Hey everybody, Dr. Rob Silverman here. I'm with Dr. Brent Dorval, one of my, without questions, I'm going to call him one of my mentors. There isn't a smartest guy in the room when it comes to food sensitivities, food allergy, truly in rapid testing. So Dr. Dorval, it's a pleasure to have you back.
It's a pleasure to be back, Dr. Silverman, and I look forward to our discussion today.
Yes, I'm happy you're available because I'm getting so many patients and colleagues asking these questions, and I wanted you to explain them, dispel any proverbial myths that people have. So I don't have to give your background. Your background speaks for yourself. Everybody knows that you're the rapid test king, HIV rapid test. You are the science officer for KBMO. Full disclosure, I also use the KBMO diagnostic tools in my office. We can go into that a little bit if somebody has a question. But the first question is people ask me, food allergies, food sensitivities, not only what the difference is, but the big question is, if you have a food allergy to gluten, let's say, or better yet, let's use a non-number, like if you have a food allergy to substance X, do you also have a food sensitivity to substance X?
Yeah. And that's very, very true and well said. So many times what happens is people develop an allergy, say, to pollen or some other environmental allergy, dust mites or something of that sort, which causes IgE to be produced. So everybody knows that's a type 1 allergy. It's immediate. You get exposed and you get the runny nose, the watery eyes, scratchy throat, or even respiratory symptoms within a relatively short time, minutes, generally a few minutes. And in severe cases, you need, epinephrine, the so-called EpiPen. So that's the allergy side of it. Now, if one is sensitized to, let's say, a seasonal allergen such as birch pollen, what happens very often is you produce IgE. So you get the symptoms associated with the seasonal allergy, but you also produce IgG against many of the proteins that are on, let's say, a birch pollen or some other allergen. And then what happens is that the allergen, birch pollen, let's use that as the example, has these little stretches, these little linear stretches, or maybe conformational stretches in birch pollen that are similar to fruits, vegetables, and nuts. So what happens is you end up producing IgG against birch pollen, and then you get cross-reactivities with fruits, nuts, and vegetables when you take something like the KBMO test. So the KBMO test measures IgG and immune complexes via the inflammatory component C3D. But so suffice to say, the IgG that's produced against the pollen ends up reacting, let's say, to a nut that you may not consume. So as a practitioner, you may say, okay, geez, you took the KBMO test and you show a sensitivity to a peanut or a cashew or a Brazil nut. And you'll hear the patient say, well, I don't consume those particular nuts. In fact, I don't like them, or they bother me for some reason. So what most probably you're dealing with when you look at the medical history is the patient has a history of seasonal allergies. The patient may even be, it may be in, like, say, the spring in the Northeast where you get a lot of pollen. So what happens is the patient's producing IgG against the pollen, and now you're getting cross-reactivity. So as a practitioner, knowing the medical history, you'll be able to sort out whether it's a true sensitivity, let's say, or whether it's something where simply a cross-reactivity. The antibody is now from pollen is simply cross-reacting with that nut. Now, the patient may have or be in the midst of some sort of allergic sort of treatment where, antihistamines, etc. And that would be a real tip-off that that sort of connection may occur.
Okay, so this is great. IgE reaction, that's an antibody, as we all know. That's usually you're referring to an allergy. It's something really quick. It's like a hive. It could be anaphylactic, which we don't want to avoid. IgG is a very common antibody. That's actually the one that we talk about that we want to be producing. If we have an antibody, 75% of antibodies are IgG. It's small.
Yes.
It's very effective in protection. Antibodies are okay. Now, this cross-reactivity, what we're talking about, and to really break it down, you're talking a cross-reactive. So if you're allergic or sensitive to something, it reacts with something that's similar in what we'll probably call a protein sequence, right?
That's
So
correct.
I'm going to use a big word. I know you know it. We're going to call it amino acid homology. So
Yes.
this protein sequence, like a zip code, is very similar. So where I am, I'm at 106.05. All the 106Os are close, and the body gets confused and responds to it. So that's the secondary reaction. Now, do you get, which is great. We got there. So my question is, do you get cross-reactivity with allergies and sensitivities, or just an allergy and a sensitivity? Or can you, I'll say?
Well, if I understand that correctly, you may get an allergy, meaning IgE, which is the mast cell basophil immediate response, and you may not get the attendant IgG reaction at all. It doesn't happen all the time, but there's a lot of recent information that suggests that it happens often enough that that IgE sensitivity is quite likely to be coincident with an IgG sensitivity. And then the flip side of that is sometimes you're going to get an IgG reaction to an antigen. It could even be a Birch antigen that may otherwise cause an immediate sensitivity. But in this instance, it only produces IgG against a certain amino acid sequence, and you don't get IgE produced. And I think it can go both ways. And I think a lot of it, those are the observations. The reasons are not well understood, but I think a lot of people would agree. I think genetics probably plays a big role in response or not a response to certain antigens, and that's very common. So I think one individual may produce both, meaning IgG and IgE, another individual may just produce IgG or IgE. And I think that as a practitioner, you can probably sort that out when you look at the medical history, understand the diet of the patient that's right in front of you.
Now, food sensitivities, let's go down that funnel.
Sure.
Food sensitivities, as I've always said before, usually imply to me that there's probably what we call a leaky gut. Everybody on this channel knows what a leaky gut is. It also means there's a digestive issue. Mm-hmm. With that being said, food sensitivities, if they're not addressed, and the biggest problem with this food sensitivity is it takes 72 hours after ingestion for symptomology to come up. So there's no way anybody knows they're sensitive without a test. They'll know they have a food allergy because they could get an immediate response within an hour. So for the docs and the patients out there, food sensitivity tests can be more revealing only because they will reveal something that is hidden. But the question with the food sensitivity is very simple. If someone has a food sensitivity and we allow it to go on, or it becomes unknown or stays unknown, can that lead to autoimmunity?
Most definitely. I mean, when antigens get through that gut wall, when it's normally pretty impervious, but due to damage from a variety of either environmental sources, antibiotics, infections, etc., diseases like diabetes or even cancer, you get damage to the gut, it becomes permeable. Antigens that normally would be excreted get through the gut wall and then start generating the immune response in the Peyer's patches, in the immune system, in the gut. And when that happens, you set yourself up, once antibodies are starting to be produced that wouldn't normally produce, the question is now, can they even cross-react with self-antigens? And in many cases, that's what happens with gluten. I can use that as one example. They call them so-called non-gluten sensitivity category, that maybe aren't celiac, but they're NGS, non-gluten sensitivity, where now this person has come up with a variety of sensitivities that may be autoimmune related, whether it's in the brain, whether it's in some other organ, that are related to an antigen that shouldn't get through there. And maybe we'll talk about that a little bit later, especially when you get inflammation by gluten, let's say, because that's kind of the poster child these days for a lot of problems in a lot of people. What happens is you get an enzyme that modifies these gluten peptides and not only causes celiac disease, but it can also set you up for autoimmune diseases on the other side as well. And they're not, again, not well understood, but what you know is if you take the patient off of gluten, they get better. So Vita Infra, the association, people say, well, it's a non-gluten sensitivity because we did the restriction of that particular food and the patient got better. If the patient gets exposed to gluten or gluten-like substances again, bingo. These sorts of autoimmune mostly can be mediated by antibodies return.
So yeah, I want to talk about gluten because I have one specific topic, but since we're just let's close it up on food sensitivities.
Yeah.
The food sensitivity test that you do, what are you testing for? What does that imply? And how can the patient understand it? And how can the practitioner understand from their perspective?
Okay, so the test that we use at KBMO Diagnostics measures IgG 1 through 4. So there are 4 classes of antibodies in humans. The test measures all of those. What happens is when a food antigen crosses the gut and causes the antibody IgG to be produced, if the antigen is around, now you form an immune complex and then activate complement. So the KBMO test also measures the inflammatory component C3D, which is covalently linked, meaning permanently linked to the antibody when it's in an immune complex. So we measure simultaneously IgG plus the inflammatory component C3D. And you may say, well, what's important about C3D? The fact that you can measure C3D indicates that you've activated complement and that C3A has been produced, which is one of the most potent inflammatory molecules in the body. And I think, as we all know and can all agree, that the cornerstone of almost every disease, whether it's cancer, diabetes, all kinds of diseases, is inflammation. So what C3A does is cause tremendous inflammation. And these are generally type 2 and type 3 type reactions. Type 2 is where the food antigen lands on the epithelium, let's say, of the kidney, which is a good example. And now complement comes along and gets activated, causes inflammation in the kidney and those sorts of diseases. Or it forms an immune complex in the serum, starts activating complement in sites where the immune complex is large. So I think, as you can see, is that the cornerstone of inflammation is the activation of complement. I mean, prostaglandins, leukotrienes, there are other molecules that cause inflammation, but one of the most potent is C3A.
And your test is a little unique in that, it's unique in that it's doing 1 through 4 of the complement. Most people do 1 and 2. And you're also testing for the CD3 and CD4, as my understanding.
That's correct. And we do that simultaneously. And that's a patented process. And KBMO Diagnostics has licensed and basically owns that patent. Now, there are other companies that kind of intimate that they measure these things simultaneously, but be careful. KBMO Diagnostics is the only company that's licensed to use that technology. So if you want a true combined test of the innate immune system along with the acquired, so the innate is complement and the acquired, which is antibody, the only test that will measure both those systems together is the KBMO FIT test.
And that's a huge takeaway. FIT test being the food inflammatory test. I think it's 183 foods. Did I get the number right? Or
Up to 176. So there's three
it's close.
panels. There's a screen panel, 22. Then there's a larger panel, 132, and then the 176. So we offer a few different flavors depending on what the patient and the practitioner feels is best.
And I really like the fact that you're testing the immune system. Now, obviously, the immune system is quite topical with what's going on out there in the world with the COVID-19
Yes.
things. So when you're able to actually test both the innate and the acquired, or the innate and the adaptive, whatever you want to call it, one of the key things, really, to piggyback on what you said on inflammation, is the balance in the immune system. When that immune system becomes imbalanced, that's maybe the leader towards autoimmunity and also a leader towards inflammation. So I've always said manage and modulate inflammation, kind of like what you said. Dr. Bland actually has said that he believes that the essence of inflammation may come from that imbalance in the immune system, which may be the next step from the proverbial visionary. So obviously the test is one I use in the office. What I also wanted to ask, I get this all the time. I tell people no gluten. And I tell them there's celiac disease when they're allergic to the protein gluten. Okay, 1 in 100 or 133, depending on where the data is. You talked about non-gluten sensitivity. It's about 4 in 10, my understanding. If those numbers changed, please give us the update. So that leaves about 6 out of 10 people that say, I can eat gluten. And my answer is no, because the gluten that you're eating now, just to start with, is there's the native versus the modern wheat, and we're eating the modern wheat. And that's where I want you to chime in and really show your expertise, if you could.
Right. Well, I mean, again, gluten has been quite topical, so to speak, as of late, especially when you look at something like celiac disease. And celiac disease is absolutely, the mechanism is well known and well understood as to why celiac disease occurs and what causes it. So we can back it up just a little bit. And so what happens with wheat? Wheat obviously is a plant with many different types of proteins and fractions of proteins. In the new world, meaning today, it's a processing thing where we make bread, and generally we don't let it, we use wheat, we use yeast to do that, and we let it rise an hour or 2 or 3 hours, something like that. And the gluten in the so-called wheat that's in the dough does not get broken down to the extent that it would if you did it much longer time, say overnight. What happens in Europe now, what happens a long time ago, is people used to let dough rise for much longer periods of time. The enzymes would degrade the gluten. So the body was dealing with the same gluten, but in the old processing, they were much smaller pieces. Today, you're dealing with gluten that's much bigger chunks, so to speak. And that's what the problem is. And Dr. Fasano, who's at Harvard Medical School, has kind of illuminated this quite a bit. And he feels that processing alone can be a big component in gluten sensitivity in people. Just the fact that you don't process things the same way. Now, let's assume we have gluten in wheat. What happens is that if you have an enzyme called a transaminase enzyme, it's produced normally. It switches amino groups and that sort of thing in proteins. It converts glutamine to glutamic acid. So, okay, I don't want to get too much into the chemistry of the weeds here, but just follow me for a second. So there's certain motifs or protein structures in wheat, protein sequences, as Dr. Silverman said. And what happens is these transaminases become activated due to inflammation, and they start converting the glutamine to glutamic acid. And then what happens is it's a multi-layer process, but it activates T cells. And then when T cells get activated, then you start to activate another class of cells, which incidentally are very important in COVID. Being not only immune to COVID, but recovering from COVID. These antigen-presenting cells are very good at recognizing a T cell antigen, and then they also recognize another, what they call it is a haplotype. I think everybody's heard of HLA-8 and 2.5 in celiac people. So if you have that combination on these cells that are activated by these peptides on the T cell, they now can activate cytokines, inflammation, and they also activate B cells, which then generate antibodies against the particular wheat antigen and wheat peptides. Now, antibodies are probably not really involved a lot in celiac, but the fact that you activate all these T cells through antigen presenting cells, so it's a loop. The peptide activates T cells, the T cells activate the antigen presenting cells because they have the right HLA antigen, the 2.5 or the 8, that cell then secretes cytokines and lymphokines, which activates more T cells. So now you get this nasty loop of, and macrophages are activated that generate more inflammation and the symptoms that you see a lot of times with celiac disease. Now, celiac disease, generally one of the markers that you'd want to measure for celiac disease would be tissue transglutaminase, so TTG is what they would call it. And the fact that if that is very high, it doesn't prove positive that one has celiac disease, but it's certainly an important indicator. Of course, endoscopy, where you see flattened villi and where there are non-absorptive surfaces now, is pretty diagnostic. But generally what happens is you get that nasty cycle of inflammation due to these deaminated gluten peptides, mostly T cell mediated, and then the patient, as a result, gets severe diarrhea and symptoms of non-absorption, even malnutrition. You scope a person like that, and sure enough, you can see regions that are flattened out and quite inflamed.
Yeah, I'm getting a whole bunch on my phone. For some reason, I'm putting it on the internet, which is fine, or in the chat. So guys, if you have questions, feel free to put it in the comments, but I will answer what we have here. Somebody said they missed it really quick. What ignites the T cell? Now, the key, what you were saying is, without question, this cascades to an inflammatory process.
Yes.
T cells come from, they're part of the acquired or adaptive immune system. They come from your thymus. What stimulates the T cell? They missed it, they said.
The T cells are stimulated not only by the gluten peptide, that's a normal one, but they also can be stimulated by the deaminated gluten peptides. So the tissue transglutaminase gets activated at a very high level, and it starts to work on these proteins, and it changes the glutamine, which is the amino acid, to glutamic acid. And that's what really pushes this from just a normal gluten peptide to something that's very toxic. And then when it interacts with the antigen presenting cell that has the right genotype. So I think everybody knows with celiac disease, people are predisposed. They don't necessarily have it, but they're certainly predisposed if they have HLA 2.5 or 8 genetic motif. So they're predisposed. So those antigen presenting cells have those HLA antigens. So when the T cell comes along, it binds by those particular HLA antigens and then activates the antigen presenting cell, which then starts releasing all kinds of stimulatory and inflammatory cytokines as well. TNF alpha, I think IL 12 is one of them. I mean, I could look here, but I believe that's another one. But suffice to say, there's a group of them which then exacerbate the inflammation, but then feed back to the T cell and actually stimulate more T cells to be produced. So it's those deaminated gluten peptides that are really the culprit here.
See, great takeaway. Here's the other question. Glutamic acid, does that make glutamate?
Glutamate and glutamic acid would be the same thing.
Okay, so it was a great question because I think I know where they're going. So when glutamate is high and released, it opens up, and again, not getting too technical, it opens up the synaptic cleft in the brain, and that we call that excitotoxicity. So you've just taken that cascade and linked it together, eating gluten, having an adverse effect on the brain.
That's a real interesting concept because I think and you mentioned it earlier about irritable bowel and about the intestinal epithelium become porous. Well, that happens because of tight junctions. And what do we know about the brain and the choroid plexus and the blood-brain barrier? They have tight junctions. So when you have inflammation, these tight junctions open up, and it's quite likely that these small peptides, and they're 10, 20 amino acids, some of them, they're small enough to get through the blood-brain barrier and cause a variety of symptoms. And they put that in the non-gluten sensitivity category, where you're not seeing the typical celiac type of syndrome, but what you're seeing is things going on neurological and mostly with cerebellum. So problems with gait and meaning walking and stability and that sort of thing. And they think it could be related in some way to these peptides, or even to the antibodies that may be produced by these peptides.
Dr. Dorval just gave you a clinical takeaway. He's saying it's very conceivable that, and I will also say it, that I share it with my patients and colleagues, the consumption and the adverse effect of gluten can damage the cerebellum. Yeah. So now you've got a food that's damaging your gut and your brain because we know that they're bidirectional. Now, there was another question. Somebody said, this is an easy one, low-hanging fruit. What's dwarf wheat?
Good.
What's dwarfed wheat?
There are probably hundreds of different types of wheat. So it's just a slightly different species of it. It's still in the general family called the Poaceae. I won't get too botanical on you, but it's in the grain family, and it's just a different species. And while I'm not specifically familiar with dwarf wheat, I'd need to look that up and bone up on it. But it's probably very similar in terms of the amount of gluten in it and gliadin. So the take home there is it probably contains gluten/gliadin. So, some grains like spelt contain a little more or a little less. In general, most grains contain about 10% of each one. So I'd have to know what the breakdown is there, but I'd want to see what proportion of really gluten and gliadin was in that.
I think when they say dwarf wheat, they're talking to what Burlong did, where he shortened the size of the wheat, right, doubled up on the protein, like you say,
right,
and processed it. I think that's, they're referring to the size of it. And you made a great point. They didn't just make it short of the wheat to proverbially dwarf it. They also added the proteins, which are a problem. And what the real point was, you said they were large proteins. We know that small digested proteins go through the gut without any issue. When a large digestive protein gets through because of a leaky gut, that's when that whole sequence that you talked about, I saw those eyes go up, that's when all hell breaks loose, if you will.
Yeah. Again, you're right. When they change the species of these things, they select out certain characteristics that they want. And one of them may be more gluten or more gliadin fraction, depending on what characteristics they want it for baking or certain breads. So they'll select that. But that also changes how the body is going to digest that particular, so pepsin and the stomach acids digest it. So it could be that a minor change may make a big difference in how one digest that food and either exacerbate or decrease, tendencies towards celiac or some other food sensitivity, because of that, the size of the proteins.
Size of the protein. As Jacqueline once said, if man makes it, I won't eat it. Not bad for a fitness guru.
He's a smart guy.
Yeah, smart guy. He was a chiropractor in 1936. Great team. Here's one for you. It's a good one. Is there a cross-reactivity between gluten and dairy? Are their sequences similar?
Yes, there are.
Sequence.
There are sequence, and again, the poster child for that one is casomorphin. So there are. So that is a big one. So what again, so if somebody was really sensitive to wheat or celiac tendencies, you'd want to say, look, you really would want to get milk and milk products out of the diet, especially if it had caseinate in it. Look at the labels carefully, because chances are that amino acid stretch will be in there. And it may not cause a problem, but you're setting yourself up for a potential problem, So there are a lot of cross reactivities that occur in other foods that are wheat related.
So there is a common cross reactivity between gluten and dairy. It would be fair to say that.
Oh, yeah, very common. I mean, I just wrote down a few before I got on just so I'd miss them. I mean, they're both alpha and beta casein. So those have stretches that are similar. American cheese and chocolate are products that would use those particular components. So you'd want to stay away from those. Casomorphin is one for sure. And they call it butyrophilin. So it's just a fat type of substance, but that contains cross-reacting components. But suffice to say, when you look at things that potentially cross-react with wheat, and I needed to refresh my memory, it's just, you can look at hemp products are really popular today, analgesics for one reason or another. Watch out there. You got rye, you got barley, you got different types of wheat. You've got sorghum, millet, spelt, quinoa. Big one today. A lot of people are eating quinoa, but that cross-reacts with wheat quite heavily, actually. You've got coffee. There's one that's kind of unexpected in people. But again, we've seen people that don't drink coffee that have high reactivity to wheat, but are also show reactivity to coffee. So again, and in celiac patients, I think many times they'll say, look, stay off coffee. Coffee, will only exacerbate the symptoms that you have. And then because you have corn, you have rice, and you have other types of things like even a potato. So there's a varied list of foods that may cross-react with wheat proteins that you probably want to, if a patient was sensitive to wheat, really sensitive, you would just say, okay, let's see if we can get these out of the diet as well, and see if we can, reduce inflammation and hopefully you feel better.
Now, I'm going to pound on a coffee because I love my coffee. And I know one thing, when I go to the Midwest and I say take away gluten, they're not happy. When I say dairy, they want to run me out on a rail.
Yeah,
so I'm not going to put you on the spot there. I'll go to the good old American beverage, Java. Yeah. Is that a regular bean, or would that also be an organic bean? I mean, we know the organic bean doesn't have the pesticides. Is it the pesticide that's changing the sequence, or is it just purely the coffee bean sequence?
I think it's certainly something that's in brewed coffee, and I mean, the association is not 100%, but I think there's enough evidence around it to suggest that it could be a problem. So it's one of those things, if you remove it, it's not going to create any harm. And if you leave it in there, it may. So if you're putting somebody on a restriction diet that's wheat associated, I would say try to get as much as you can out of the diet that would be related to wheat. And that may even include other grains, if you feel, if you really feel strongly about that. And different practitioners have different protocols. So that's the other thing. But I think I would suggest that.
Yeah. Another great question. Again, they're hitting me here. So it's a good thing the phone's working, because we never know with Facebook.
That's true.
Yeah. Here's the question. dairy intolerance. How's
Yeah.
that different than a sensitivity?
Yeah, dairy intolerance is most likely an enzyme mediated types of thing, and the one there I'm thinking of is lactose,
Mm.
and that's certainly genetic in many ways, and there could be other enzymes as well, but really the big one there would be lactose and not having the enzyme lactase. So that just means you don't digest it, and as a result, you end up with stomach and bowel problems and other problems as well as a result.
The other, he just followed with a question. It's good. If somebody has an intolerance,
Yeah.
do they also get an inflammatory response?
Oh yeah,
Is
most definitely. Yeah, most definitely. I mean, anytime you're not digesting something, then normally, then a part of your body has to deal with that, and generally, you start getting into, inflammatory response either due directly to, something like that could be activated, like prostaglandins or leukotrienes that generate inflammation. So that would be like non-immunologic, or the body says, wait a minute, it's gotten through the gut, this isn't good, sets you up for food sensitivity, and now you start that nasty cycle of immune complexes and generating inflammation due to activation of the complement cascade. So there's a variety of inflammatory processes that can kick in as a result of an intolerance, for sure.
So food allergies, food
Yes.
sensitivities, food intolerances all have a reaction with the immune system and can cause inflammation. So a
Yes.
fair statement, food is a
That's yes.
fair statement.
Yes.
Food is a potentiator for inflammation,
Yes.
where it should be the potentiator for health information.
Yeah.
And the easiest test and the one that's most recommended, not to say don't go for intolerances or allergies, I'm going to guess you'll say food sensitivities because that's the widest ranging.
I mean, I just think food sensitivities is, I've been in this for a few years, and they were kind of underrepresented. In Europe, they had figured out a long time ago, really, I mean, a couple decades ago, that, what are you exposed to most in your life? Air, water, and the food you eat. So if you're sick and things are going on, you can look to the air many times. Sometimes it's stuff in water, but a lot of times it's food. And I think what happens is food sensitivities are generated in a lot of people, and they went underreported for a long time. And I think if you identify foods that it doesn't, because you test positive on a test, it doesn't mean you have a food sensitivity. But if you can show by elimination and challenge that this food causes symptoms in your body, then I would say, whether it's diarrhea or a headache, stomach problems, it's probably a good idea not to eat it. And a test like the KBMO test is very good from the perspective, if you remove a component from the diet, as long as you're not malnourished, is a high likelihood inflammation is going to be reduced and you're going to feel better. So there's no chance of harm and a high likelihood of benefit. And where you're exposed most is food. So that's where I look to say, look, let's look at foods. Let's see if they play a role in how you feel. And let's systematically try to figure out which food may cause a problem and see if we can't run it to the ground. And it's not, people are never cured if you remove a food sensitivity. I would run from anybody who said, oh, you take a food sensitivity test, and if I can find the sensitivity, I can cure you. I don't think that happens. But the goal is you remove the food that causes inflammation and patients feel better. Is it 10%? Is it 50%? Is it 80%? But the reduction in inflammation will make the patient feel better. And I think that's the overall goal here, is to identify a food and the patient will feel better.
Most common food groups or foods that you find people sensitive to.
Yeah, absolutely. It's the big eight, so to speak, the dairy, the wheat, the grains, the seafood, the nuts, etc.
Eggs,
So those are the
nuts.
ones, even worldwide, that people eat most frequently. So it's not surprising that most often food sensitivities and even food allergies fall into that group. And when we look at a patient group at KBMO of tens of thousands of patients, even more than that, what we find is mostly dairy, meaning milk and egg and wheat. Probably about 60% of the patients that are having food sensitivity related issues are sensitive to one or more of those particular components. So those really stand out as like the big three in my mind.
A good buddy of mine, Dr. Jordan Robertson, asked, can you explain the difference between IgG 1 and 2 versus IgG 1 and 4? What is 3 and 4 telling us?
Okay.
So why are you incorporating 3 and 4? What does it give you?
Excellent point. Excellent point. So IgG 1 through 4 are tested in the FIT test. So IgG 1 and 3 activate complement very, very strongly. They're strong activators of complement when they form an immune complex. IgG2, a little less so. So it will activate complement, but half, maybe a third of IgG1, let's say. Whereas IgG4 absolutely does not activate complement. And it's rare in biology or medicine, you can say absolutely zero. But IgG4 does not activate complement at all, even when bound to antigen. So where does that become important? So this test measures, KBMO FIT test measures IgG 1 through 4. So a person could be positive on the FIT test, and because it measures all those classes of antibody as well as the immune complex, but not show a food sensitivity, because in general, if you show a high reaction to IgG4, you're not going to activate complement. You won't generate the inflammation that's associated with immune complexes, and you won't generate the symptoms as a result. So they're more of a protective antibody in that they'll bind antigen and remove it from the body. But in general, I'm going to say in general, you don't have the attendant intense inflammation associated with an IgG4 response. So fast forward, when you do an elimination diet, you could show a sensitivity, let's just say, to casein, and you remove it from so we had a 4+ to casein. And when you remove it from the diet during elimination and then add it back, the patient eats it and says, eats it on Monday and says, Tuesday, Wednesday, Thursday, geez, I feel fine. Try it one more time the next week. Same thing. So what happens is the patient is probably skewing the IgG response towards IgG4. So it's really not causing the symptoms. So when you do the test phase with the elimination and challenge, what you're seeing is that, the patient's producing an antibody. What's measured here is most likely IgG4, but it does not generate the inflammation because you're not seeing any symptoms that are associated with this food. So just keep that in mind, that really the FIT test is a screening test. It tells you what may be a food sensitivity, and the elimination diet is really the gold standard. That will tell you which food or foods really caused the problem for the patient. But what we advise is, if someone shows, let's say, a high response to casein as the example, but no symptoms, we'd say, look, what we would say is rotate that in your diet. I mean, it's probably not a good idea to have a hyperreactive IgG4 response. So you may want to think about, see if you can't eliminate that. Not eliminate it, reduce that in the diet and rotate it, and see if you can't reduce that IgG4, which is most likely somewhat. It's much like you want to reduce CRP in a person, or you want to reduce cholesterol. So it's like, okay, how much is too much? Well, I don't really know, but I would say less is probably better.
Great. I know in the interest of time, I know you're busy. So last question that somebody asked
Sure,
was,
please.
how can they get in touch with you?
Again, I'm available at KBMO all the time, so they can reach me by phone, and I'd be happy to, or Dr. Silverman, you can supply that. So my phone number is simply 508-654-4451. That's my cell, and my email is CSD, so Charlie Sam David -BLD, Boy Larry David, at att.net. So send me a question or comment. And one thing I'll do is I get back to people right away. And I know people are busy. And in this environment where everybody wants an instant response, I try to be just as instant. So I'm happy to answer your questions. And even if they're seemingly unrelated, happy to do that.
And if you're a practitioner interested in joining KBMO, you can go to the KBMO website, just say Dr. Rob's podcast or Facebook.
Right.
James White will take care of you. Dr. Dorval, it's always a pleasure. It's a learning experience for me every time we speak. I appreciate you. Thanks for taking time to come on today.
Well, it's a pleasure to be on. And like I say, thank you, everybody in the audience. And if anything comes up, just give me a holler.
You got it. Everybody, Dr. Rob Silverman, Dr. Brent Dorval. Always
Thank you very much. Have a great day.